So these are coming out of those cookbook hypothesis tests that I had in last week's discussion forum. And I picked these problems because they're different kinds of problems, and they help you decide and answer those questions you ask about two-tailed test, right-tailed test, along some other things that might help you. So this is about so here's some things I'm noticing. The first thing you want to do is make sure that you're going to run the right test. So what I'm seeing here is, you see how they told us the population? This is coming from the population. That's not coming from a sample. So this is a population standard deviation. And so because of that, we can run a z-test, not a t-test, or it's not about proportions because it's a quantitative variable. So I know, so I'm going to run a one sample z-test, and there are applets that'll do this. I'm just going to show you how to do this by hand. This is a pretty easy thing to do by hand, and it's probably good to know how to do one by hand. So they claim that, here, let me get a pointer going here. The claim is that the manufacturer's claim that the mean life of its best battery is 54 months. So then they go out, and the consumer group decides to check that claim, and they go out and get 50 batteries and put them through the tests. And they found that their sample of 50 batteries had a mean life of 52 months with the standard deviation 6 months. It's good that it was a population, same as population standard deviation, but because we know the population standard deviation, we're going to use that and not go with the sample standard deviation. So what do we do? Well, our null hypothesis is that they equal 54 months, and because they aren't telling us whether, the consumer group could be thinking, well, maybe that the life batteries don't last that long, because if they last longer than that, that's a good thing for consumers. But since we could go either way, we could either go with a two-tailed, or a left-tailed test or two-tailed test. And I didn't have another two-tailed test problem pulled up. I thought I'd show you how to do this as a two-tailed test. So we don't know if it's greater than or less than 54 months. The true average is greater than 54 months, less than 54 months, just that it's different. That's what's going to make it a two-tailed test. And then to get the p-value is two tail areas that you're going to worry about. I'm going to show you how to find those. So we're going to run a z-test. So this is a z-statistic. Let's see, was I supposed to talk about anything else there? I don't think so. So there's the sample mean. You know what I should have written here? I should have written the x bar is 52. And of course, we know the population standard deviation is 6. And we know the sample size was 50. So if we do that calculation with the z-score, because this is a sampling distribution, I'll do the sample mean minus the mean we have in our hypotheses. That's the hypothesized population mean. And I get to divide by the standard deviation for that, for the sampling distribution. The standard error is another name for that. So you do the standard deviation divided by the square root of the sample size. You get that. I divided that. That's what I got for a z-score. So now I got to figure out, I could do this with critical values, but p-values work pretty well. So I'm gonna use a p-value. So what I'm gonna do is I'm gonna go into that z table, and I'm gonna look up. Oh, how about that? It didn't hold my yellow scan. So I'm gonna look up a z-score, the probability of getting a z-score that low or lower. So the negative 2.3 row, the 0.06 column, and that's the p-value, and that's what that area is right there. Okay, that's that area to the left. So this area right there is to the left. We've got to find the other area and go to town on it. One last thing before I leave this page is we got to decide which hypothesis is the claim. So see how the manufacturers that they're making that claim, and they're just checking, the consumer group is checking the claim. So I'm going to call, let's see, how do I do a highlighter? I'm going to call HO the claim. Okay, that's important when we make our final decision. So because normal curves are symmetric, if we know that the area to the left is the 0.0091 from the table, the area to the right of positive 2.36 is also the same. So the p-value is just that tail area doubled, and that's what happens with a two-tailed test. The tail area gets doubled. So that is 0.01. Now, in this problem, they didn't tell us the level of significance, and because, I mean, maybe somebody could argue that somebody's going to lose a lot of money if they buy these batteries. I'm going to say maybe not, so I'm going to use a level of significance of 0.05. Now, since that's the cutoff, and our p-value is less than that, we're going to reject HO. That means it's a small enough chance of being wrong if we reject HO to be acceptable. So then what we do, how did I write this concluding statement? So because we said that HO was the claim, this came from the table in the textbook. You see the page number. So HO is the claim, the null hypothesis supports the claim, and we're going to reject HO. So this is how I decided to do that writing for this conclusion. I said there's not enough data, or there's, oh, sorry. Did I write the wrong thing? There's enough data. Oh, see, there you go. Yes, I did the right thing. I don't know what I was looking at. There is enough data to reject the claim, that there's enough data to reject the claim, and you got to copy the claim down, okay? So that's how you do that for this two-tailed test and run that one sample z-test. Now, what about this problem? This is about, let's see, some advertisement says some kind of new fertilizer will increase yield, and farmers will get 500 bushels of soybean on average out of their per acre by using this fertilizer. So 50 farmers who belong to a co-op plant it and test it, and maybe this fertilizer is expensive to buy, more expensive than they usually do, so they want to see if that claim's right. So, and I decided to make the H1 be the claim this time. I mean, you could have just as easily done HO be the claim, and it just, all that matters is how it changes the phrasing, the conclusion. But I decided to do this. Now, what test am I going to run? For one thing, how did I know it was going to be a left-tailed test? One way, if this is the hypothesized center, and our sample mean is less than that, I'm thinking we should go with a left-tailed test. So that's how I made that decision. Then I get to decide, do I want to use a one sample Z test or a one sample T test? Now, in this case, we don't know the population standard deviation. We aren't told that. We also aren't told anything about the parent population, like the shape, but we are told that there's a sample of 50 farms. So N is 50. So because the N is 50, we're okay, or more than 30, we're good to use a one sample T test with this. So that's what I'm going to run, is a one sample T test. And that takes a little bit more to do it by hand. So I don't know if you watched some of my other videos, I recommend using this Rossman Chance applet, and that is available in Canvas. Here, just a minute, I'll show you, we can click on it. So in Canvas, if you click on modules and then click on drop course resources, you see this online statistical tools. Click on that. And that opens this page, and then you want to click on 1 and 2 sample confidence intervals and click on that link. And that'll take you out to the Rossman Chance website. And that'll take you here. And what you want to do is, let's see, where's my pen? You want to select on this little drop down here, you want to select one mean. Then you want to fill in your information, the sample size, the sample mean, and the standard deviation. Notice you're saying sample standard deviation. And then check tested statistics, significance test, and then fill in your HO and H1. That's why it's important to write H1 beforehand. See, I did that up here. And then you click, then you can click calculate, or often click calculate, and it'll often fill it in automatically. And here's your t-score. Here's the test statistic. You want to report that out. Here's your p-value. Notice how it's given us our left-tailed test, and we said it was a left-tailed test, and we know that's going to be our p-value. And before I leave this, one error that people make is they select the wrong HA or H1. And if it's filling in this side, so it's not a tail area, you know you're going the wrong way. So you got to fix that, okay? P-values will always be less than 0.5. So they didn't tell us. They didn't tell us a level of significance. Somebody could lose a lot of money if they went with the wrong direction. So I'm gonna recommend using a 0.01 level of significance here. But honestly, it doesn't really matter whether we use 0.01 or 0.05 because that is a huge p-value, which means this is not unlikely to happen just due to chance. So we're going to fail to reject HO. And then if you go back and look at that table, that table out of Dr. Stevens, this is the alternative hypothesis supports the claim, and we're going to fail to reject HO. So this is how you start it. There's not enough data and then to support the claim and then you fill in the claim. Okay? So we know it's a left tail test because we compared the sample mean to the hypothesized mean, and we ran this applet. Now this one is about roses, and let's see, what do they tell us? They tell us more than 1,000 florists in the city have an average of $20. An organization, local nurseries, felt that figure was too low. I'm going to call that the claim. I know the newspaper claimed it, but these people that are running the test, they think that $20 figure is too low. So I'm going to make this be the claim, which means, and the hypothesized center is the 20, so that's why I said HO is 20 and H1 is greater than 20. That's the claim. Now, I don't know the population standard deviation. So then I got to ask myself, do I know anything about, and I also see, before I go there, see how they only sampled 16 florists? We're supposed to have 30 or more. But we're okay because we know the population distribution of rose price is approximately normal. So even though we don't have 30 or more in our sample, because we know the parent population is normal, we're good to use, so here again, we're going to use a one sample t-test, not a z-test. So then again, I used Rossman chance. I did the, selected one mean. I filled in my information. I made sure I selected a right tail test. Did I talk about how I know this is a right tail test? I know this is a right tail test because my sample mean is a lot bigger than the hypothesized mean. So our right tail test works. So I ran the test. I don't know if I can blow this up. Oh, I can. See how the test statistic is that and the p-value is that? You'll want to report that out. And we're going to reject HO because that's a very small p-value. That's less than 0.05. So using that table again, I said that H1 was the claim. We're rejecting HO. There's enough data to support the claim, that blah, blah, blah. Okay? One last test, because it's about proportions, I wanted to show that to you. Because this is a little weird. I said a right tail test or left tail test, and that's why I did this one. So this is school officials claim that at least 85% of the students who graduate from their school have a college degree or enrolled in a college degree program. I see the percentage. They aren't telling me anything about a standard deviation or anything, so I know this is going to be a proportion. I think I'm going to use a one proportion z-test, one prop z-test. Now, to make sure we can, you remember how we had to say with the means, we had to say either the population was normal or we had to have that sample size bigger than 30, or we had to know the parent population standard deviation. In this case, we have to do this condition check. Take your sample size times that hypothesized percentage, and that has to be bigger than 5. And then the other side, sample size times 1 minus that hypothesized center. And both of those are bigger than 5. We know the sampling distribution is normal. We're good to go to run this one prop z test. So what I did is I said, here's their claim. And so I said HOP for the proportion, because it's a one prop z test, is equal to the 0.05, that claim. And then they went out and did the sample, and this is why I picked this problem. Here's the sample proportion, right? 47 out of 60 is less than 0.85. So to make sure we get that tail area, I made this be a left tail test because this is less than a higher hypothesized proportion. Okay, So it's left-tailed. I did the condition check. So I went out to Rossman chance again. I selected this time, because it's about proportions, I had to select a one proportion drop down. Now you know you're doing this wrong if you're not seeing n and count. If you're still seeing mean standard deviation, you know you have the wrong test. And conversely, if you're doing a test about means and you're just seeing this, you have to change the drop down. I think this is the default. I think this is how the page opens. So you put in your count and your sample size and your count, click calculate to give you the p-hat. Of course, we knew that. And then we got to set in your hypotheses that you set up, and then make sure it's left. And there's our test statistic. There's our p-value. They're saying test at the 10% level of significance, which is huge. So we're going to reject HO because our p-value is less than our level of significance. And then because I said HO was the claim, the null hypothesis supports the claim, we're going to reject HO. So there's enough data. Is that how I worded this? There's enough data to justify the rejection of the claim that, and this is a long claim, so I wrote it all out. Okay, I encourage you to use the Rossman Chance website for the t-test and the one proportion test. In chapter 9, when we get to the two-sample t-test, two-sample test, I mean, it just saves us a lot of time. Okay, and it's a lot of effort. Okay, hopefully this helps. Let me know if you need more help.